Okay, in this video I'm going to try and explain the relationship between magnetic flux and induced EMF in an AC generator. So from a previous video I showed you that the graph of magnetic flux against time, when we have a coil rotating in a uniform field, looks like this. It's a cosine function basically. And now let's plot on the graph of induced EMF. V, which is going to be the red graph. Now, Faraday's law tells us that the induced EMF is the negative of the rate of change of magnetic flux, which is basically the gradient at any point on this graph. So if I was to put a tangent to the curve here, 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 and here, the gradient is 0 because it's a maximum or a minimum. Whereas at this point here, the gradient is maximum and negative. Here the gradient is maximum and positive, and so on. It goes on cyclically. So in mathematical terms we can say that the graph of the EMF is the negative of the derivative of the graph of magnetic flux. So let's just plot that here. Using GeoGebra we can quite simply plot that using the function derivative. So wherever we have a maximum in the graph of magnetic flux, we have a 0 in the graph of induced EMF or voltage. Wherever we have a minimum, we have in the graph of magnetic flux, we have a 0 in the graph of EMF, and so on. But where the graph has a maximum negative gradient for magnetic flux, we have a maximum in the graph of EMF, and where we have a maximum gradient in the graph of magnetic flux, we have a minimum in the graph of induced EMF. Now, the important thing you have to know is the effect of changing the frequency, so how fast the coil rotates within the magnetic field. So let's see what happens when we reduce the frequency. So by reducing the frequency, the graph gets stretched out, i.e. the period becomes greater, but also the maximum EMF, the maximum in the red curve, also decreases. However, if we were to increase the frequency, you see that the period becomes smaller, but also the maximum of the induced EMF increases, and in fact it's a linear proportionality. So decreasing the frequency increases the period but decreases the maximum EMF. Increasing the frequency increases the maximum EMF.